7. Please report.
We're gonna see what you're gonna put on there.
Right here. I got it.
27. Let's try it. TNT contestant number 27. Please report to the competition area and immediately your flight is ready for departure. And let's have a big round of applause for TNT contestant number 27.
Yay!
Dinner has been delayed. Compliments of him.
Tester, right? That is yours, compliments of Fluke. Put that away, that has nothing to do with the competition at all. Right? That is your prize from Fluke for making it to round 2. Right? Round 2 is going to test your troubleshooting skills on air conditioning systems and heat pump systems. So you are armed with a sheet that has slide 1, slide 2, slide 3, slide 4, slide 8. There's a bonus slide, and you're going to have to do some calculations down along the bottom. You should have a pad for calculations, PT chart, right? Everybody has it? All right. So here's what's going to happen. This is a timed event, but it's not a timed event. You're going to see a slide. It's going to have a number up here. So we say 1 through 8. That's a slide number. Based on the information, when you're looking at a schematic of an air conditioning system or heat pump system, you're going to have pressure readings, temperature readings, and based on the information you see, you are going to write down what the most likely cause for system failure is. Okay? It's nothing crazy, not like the sun rays are reflecting off the roof, causing thermal conduction through the condenser. It's nothing crazy. Here's the kick. There is a 4-minute time limit per slide. So, they certainly know how to calculate heat and subcooling. They know how to do that. Right? You're going to have ambient temperatures, operating pressures. You got your PT chart. Simple system malfunction, okay? The ones you're used to teaching. Overcharges, undercharges, condensing, airflow problem, or low side airflow problem, right? Nothing crazy. Having you do this, I've printed these slides out on foam core, and they're down my hallway in my program. As the students walk down, they're looking at these things and they're troubleshooting. So you 20 guys are going to get these emailed to you. You can print them up on foam core and you slam them on the walls of your program and watch your students freak out. It's really cool stuff, right? So the minute you see, not the minute, the second you see slide 1 come up, you're going to figure out what the problem is. You're going to write the problem where it says slide 1. The minute you finish, you're going to hold your clipboard up in the air so we can see the number on the back. And that's going to be the tiebreak. We're going to grade them all real quick when you finish, but we also want to see who finishes first, second, third, fourth. And that's going to be the tiebreak. So if you finish in a minute, you put it up, you tie with somebody who finishes 2 minutes later, you get the nod to make certain that you put the clipboard up. Yeah. All right, and then you have to wait until the next one comes up. The trick is, if you put your clipboard up, and then you put it down and you start writing again, you just knocked yourself out of the competition. That means you're finished with that and you don't write anymore. Once that goes up, you stop writing until this number changes. Are we cool? 4 minutes per slide. I'm a little high. Well, that's... Oh, for that? I'll give you a towel. go and start. Is that better? Yeah, you can start. If you need the calculator, you can go. That's not what this, that's not slide over. You want to slide over to give yourself some more room? Just make sure you can see the screen. Just ask the second one to move a little bit to the left. Luke, are you feeling better now? That's good. All right, just I am.
What are you doing? Doing the selfie.
Hey, I got my Christmas juice early. What's up?
The fan crowd.
I can't because.
They will be.
No, we can't. Because we remove the screen back, this is just as tight as it gets.
We had some late attendees.
Right. It's as small as I can make it. Move it back, move it to the side. Can we deal with that? On your mark. Ready? Everybody set? No? Well, have fun. Oh, look at it. Oh, that's an issue. Yeah, that's a problem.
You have to move.
So for those of you guys watching, I have these printed on foam core, 2 foot by 3 foot posters, and I have this whole series up and down the hallway in my program. So as the students are walking down the hallway, they're looking and they're stopping and they're trying to troubleshoot systems while they're walking to class. And I did these about a year ago. And if I tell you there was a noticeable increase in student performance, I'm telling you, students are coming to class early to hang out in the hallways, all right, to just seek, and every so often we would change them up. We actually have about 50 of these, and every so often we would just change them. And the guys would get to class early just to walk up and down the halls and look for new problems.
So right here, it says it's operating in heating mode, but it's operating.
What's the problem? And he says it works.
Right, well, yeah, they have it.
It's got a problem in cooling, but it works okay in heating.
Where did it say there's a problem? It seems like total shock.
Well, okay, maybe there isn't. You have to analyze it to see if there is.
Because it's saying it's operating in heating mode.
No, it doesn't.
No, the system operates properly in the heating mode.
You have to look at it and see, is it,
That system,
is there something wrong
that
with
system
doing
is,
that?
this system is in the cooling mode right now. Right?
But is there any wrong?
But it operates properly in the heating mode.
But not in cooling. I got it.
Right. Well, who knows? Maybe the system's working perfectly. And they just write down, oh, the system's working perfectly. But that's not the case.
So it's
And if those were 22, I would know my pressure. I know it. If it was 22, I would know, but
without looking at the PT chart.
yeah.
Just look at if you're indoor, if you return your 75, you're going to about 55 coming out. Actually,
Yeah, but what's 145 and 14A?
145 and 14A suction pressure
Would that be
probably
44 degrees for Denver super
Oh,
heat.
no.
Number 6 is done. Followed by
145, about 115 is about 45 degrees.
Yeah.
yeah.
got high suction.
Yeah, it's just to keep track of,
And the fact that the suction temperature is 15
And it's got high head pressure. Well,
that's pretty normal.
really go through steam.
You gotta look at 95 amps.
these are all up and
You've
down the
never seen
hallway.
95 amps.
oh, you guys don't?
Hell, we don't. I don't.
Yeah.
Not where I'm at.
Yep. Well, I'm trying to think of.
You're down. Where are you at? You're wall to wall, right?
Well, Kennemark. Yeah.
Yeah. Well, you see it, but we don't. Hell, I'm in Bellingham.
Right. We see
know,
100 degrees opposite.
You know what our mass rate is room temperature is in Bellingham? 79 degrees.
You're kidding.
Summer design temperature. I
Slide
mean,
2
nobody
in 5
uses that, but
seconds.
that's the actual recommendation.
Ours is 100.
2.
Ours is I've got a restricted metering device that's not going to be right
No.
because you won't have high head with a restricted metering device. But I'll bet you that's the answer.
That's okay.
You could say non-conventional,
Well,
but that's so unusual. That
Exactly.
It's almost an issue. It's a non-issue because you just don't see non-conventional unless the person working on it is an absolute idiot.
right. It's pretty high. It's pretty high subcooling temperature based on, well,
Not really,
95. Yeah, that's 15 or that's
Well,
10
you-
degrees. 10 degrees subcooling. So if it would be restricted, well, plus my subcooling is way high.
Yep. And you wouldn't have
It
high
isn't.
head. This is non-conventional.
That's weird.
But the problem with this is
Well, that's just it. We'll just take the timing now. We're gonna get it back.
Nope, my battery's dead. Yep.